Hello students, welcome to educators.com. I am your maths tutor Sidra Zafar. Today we are going to study numbers and accuracy. Let's start. What are the numbers and why these are important? So we will start from numbers. We use numbers in our day-to-day life. They are often called numerals. Without numbers, we cannot do counting of things, date, time, money, etc. Sometimes these numbers are used for measurement and sometimes they are used for labeling. The properties of numbers make them capable of performing arithmetic operations on them. These numbers are expressed in numeric forms and also in words. For example, 2 is written as 2 in words, 25 is written as 25 in words. There are different types of numbers in math which we learn here. So our next topic is types of numbers. Let's start from natural numbers. The numbers which are used to count are called natural numbers. They start from 1 and 1, 2, 3, 4 and so on are natural numbers. For natural numbers, the letter capital N is frequently used. The next is whole numbers. Natural numbers including 0 are known as whole numbers. For whole numbers, the letter capital W is frequently used. The next one is integers. Integers are whole numbers, but they can be positive or negative. Starting from 0, and this will be positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 4, and so on. These all are integers. For integers, the letter capital Z is frequently used. We can categorize integers as positive integers and negative integers. So positive integers are positive 1, positive 2, positive 3, positive 4 and so on. Negative integers are negative 1, negative 2, negative 3, negative 4 and so on. Positive integers are denoted by Z with positive sign and negative integers are denoted by Z with negative sign. Neither positive nor negative. Can you guess which integer is neither positive nor negative? If you said 0, you are absolutely right. 0 is the only integer which is neither positive nor negative. Let's move to reciprocals. A number's reciprocal is obtained by dividing it by 1. For example, let's say we have a number 4 and its reciprocal will be obtained by dividing this number by 1. So it will be 1 over 4. Any integer will equals 1 when multiplied by its reciprocal. So let's multiply 4 with its reciprocal, which is 1 over 4. Now this 4 will be cancelled with this one, and the answer is 1. The reciprocal of 3 is 1 over 3, and reciprocal of 1 over 3 is 3. Similarly, reciprocal of negative 1 over 3 is negative 3. The reciprocal of a number n can also be expressed as n raised to power negative 1. Because we can write n raised to power negative 1 as 1 over n. So that means the reciprocal of any number n is 1 over n, and we can express it as n raised to power negative 1. Next is rational numbers. A number which can be expressed as a ratio or fraction of two integers, where denominator should not be 0, known as a rational number. That means there should be two integers, let's say p over q, where q is not equal to 0 and p and q belongs to integers. For example, 0.3 recurring, this is equal to 0.333 and so on, which is equal to 1 over 3 is a rational number, because 1 over 3 satisfies all the conditions of a rational number. 1 is an integer, 3 is an integer. We can write them as, these are written in fraction, and 3 is not equal to 0. Next example is 0.25. We can write it as a fraction of 25 over 100, and in simplified form it is 1 over 4, which is again a rational number. The next is irrational numbers. A number which cannot be expressed as a fraction of two integers, known as an irrational number. For example, pi, square root of 2, square root of 3, square root of 5, these all are irrational numbers. We cannot write them as a fraction of two integers. The number square root of n is an irrational number if n is not a square number. But what if n is a square number? Let's discuss this. Let's say n is a square number. So we can assign n a value 4. 4 is a square number because 4 is equal to 2 square. So if n is a square number, then it will be 4 square root of n. This will be equal to 2 square and its square root. This will be cancelled. The result will be 2. And we can write 2 as a fraction of two integers. Here 2 and 1 belongs to z, and 1 is not equal to 0. Then this will be our rational number. But if n is not a square number, then this will be an irrational number. Any multiple of an irrational number is also irrational. If we multiply these irrational numbers with any number, the result will also be an irrational number. Here we have an examination tip. In the exam, use your calculator to your advantage. If you are not sure whether a number is rational or irrational, plug it into your calculator and see if it can be represented as a fraction or not. Here we have a worked example of an irrational number. The question is, explain why square root of 7 is an irrational number. Pause the video here and try it yourself. Now let me solve. Square root of 7 is an irrational number. The reason is that because it cannot be expressed as a fraction. Now here we will use our calculator to our advantage. We just put square root of 7 in our calculator, then press equals. The result is again square root of 7. And when we convert it into decimal or fraction, the result is 2.6457 and so on. Okay, so we cannot write it as a fraction of two integers. That's why this square root of 7 is an irrational number. The next is real numbers. Real numbers are the numbers which include both rational and irrational numbers. For real numbers, the letter capital R is frequently used. For example, these all are the examples of real numbers, where we have 2, -3, 2 over 5, square root of 37, 4 over 5. Next is multiples. The outcomes of the times tables are the multiples of a given number. There is an infinite list of multiples of every non-zero number. For example, multiples of 2 are 2, 4, 6, 8, 10, 12 and so on. Multiples of 6 are 6, 12, 18, 24, 30 and so on. Next is factors. A natural number that divides a given integer perfectly is referred to as a factor. Every number has itself and 1 as at least 2 factors, which means every number has at least 2 factors minimum. For example, factors of 4 are 1, 2 and 4. 4 can be divided by 1, 2 and 4 perfectly. Factors of 8 are 1, 2, 4 and 8. Next is prime numbers. A natural number with only 2 different factors is known as a prime number, and 2 different factors are 1 and the number itself. For example, 2, 3, 4, 5, 7, 11, 13, 19 and so on, these all are prime numbers. They just have only 2 different factors, 1 and itself. Keep in mind that 2 is the only even prime number. The rest of the prime numbers are odd. Next is square numbers. A number which is the result of multiplying a number by itself is known as a square number. For example, 4, 9, 16, 25 and so on. 4 is the result of 2 times 2, so this will be a square number. 9 is the result of 3 times 3, so this is the square number. 4 times 4 is 16. So 16 is a square number. Then 5 times 5 is 25. So 25 is a square number. So 4, 9, 16 and 25 are square numbers. We can write x times x as x square. First 10 square numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81 and 100. Next is cube numbers. A number which is the result of multiplying a number by itself twice is known as a cube number. For example, 8, which is the result of 2 times 2 times 2. So 27 is 3 times 3 times 3 and 64 is 4 times 4 times 4. So 8, 27 and 64 are cube numbers. We can write cube numbers as, let's say number is x, then x times x times x, it can be displayed as x cube. And first 10 cube numbers are 1, 8, 27, 64, 125, 216, 343, 512, 729 and 1000. The next is indices. A handy approach to write a sequence of multiplications of the same number is to use an index, and its plural is indices. For example, they are frequently referred to as powers and exponents. For instance, let's say we have a number 5 times 5 times 5 times 5. We can write it as 5 raised to power 4, which is the number 5 multiplied by itself 4 times. And if we have this number, which is x times x times x times y times z, so we can express it as x raised to power 3 times y times z square in index form. Here we have some questions for you to solve. The question number 1 is, complete the list of factors of 49. The first factor is given, which is 1, and the last is 49. You have to complete this list. This is a 2-mark question. You have to solve it by yourself. The question number 2 is, write the numbers 7081 in figures. You have to write 7081 in figures. This is a 1-mark question. Question number 3. Write all the multiples of 13 less than 50. It's a 2-mark question. You have to write multiples of 13 which are less than 50. Question number 4. Some numbers are given: 32, 33, 34, 35, 36, 37, 38 and 39. From the list of numbers, write down a multiple of 8. It's a 1-mark part. A square number, again a 1-mark part, and a prime number, which is a 1-mark part. Question number 5. Again some numbers are given. From the list, Write down a number that is a cube number. It's a 1 mark question. A multiple of 3 is a 1 mark question. A prime number is a 1 mark question. And an irrational number, again a 1 mark question.